lot of our beta testers are calling it about 10 years. I've been around After Effects for quite some time, as Jeff so eloquently put. But basically, we've really focused on performance. Performance has been a primary driver of what we've done in After Effects CS6. And just to give you an idea, we've also got some other great features. You can check out 3D Camera Tracker or 3D Ray Tracer. But for those of you who do motion graphics and visual effects, there's sessions within the Post-Production World Conference, and obviously please stop by the booth and see what we're doing. Specifically today, though, what I want to talk to you about the global performance cache. So for those of you who use After Effects, we really, starting about 2 years ago, right when we released CS5, obviously the Mercury playback engine in Premiere Pro was a huge boost in terms of Premiere Pro as an on-layer editor. But we wanted to look at what are the things that people do within After Effects, irrespective of the kind of work that they do, no matter what. And that one of the things that we really focused on were previews. And previews, an artist does basically as much as they breathe. It's something that, you do something, you try it out, you want to see what that idea that you have in your head on the screen. And we really decided to essentially go underneath the hood and rip apart everything and see what we could do to optimize that workflow. So one of the things we followed from a principal perspective is we got very green. We're very environmental in After Effects now. And we really focused on this simple philosophy. And the idea is recycle, reuse, and repurpose. Never render unless you absolutely have to. And we made huge strides with that in After Effects, but then we started looking, okay, where's the bottleneck with something like this? And that's where we really started looking, okay, well, it's I/O. It's on the disk. We really started bringing a lot of things fast from the disk, and with the advent of SSDs and technologies like Thunderbolt, we were really looking at how we could optimize After Effects to do that. But then we kind of took it another level. We wanted to go and we wanted to talk to some folks that have really been taking performance to the extreme from that perspective and make sure that After Effects, as a first-class citizen, could understand and deal with probably one of the, I think, the biggest revolutions in storage in a long time. So with that, I'm going to introduce Vince Bispo.
Thanks, Steve. So a lot of you might not be familiar with Fusion IO, but you actually use us every day already. When you booked your flight for Vegas, you were using Fusion IO. When you checked Salesforce.com to set up your meetings with your clients, you're using Fusion IO. When you took your laptop and synced it to the cloud so that your files would be safe, again, you were using Fusion IO devices. And even on Facebook, when you posted your Facebook message a bit earlier saying how excited you were to see Woz and Rob Legato here today, you were using Fusion IO. So what we're doing today is we're bringing our enterprise-grade performance and reliability that you're already using in data centers down to the workstation. So we're making it available to everyone to really accelerate everything you do on a daily basis. So we're announcing today the IO effects, which is this card right here. It's a Fusion IO device, and I'll turn it on for you there. It'll actually light up inside your system. And what this is a 420 gigabyte memory device that connects through PCI Express and performs very, very rapidly, under microseconds of latency. So what's really important to note is this is not an SSD. There's no SATA, there's no SAS, there's no RAID controllers. It's NAND flash memory attached natively to the CPU for speed. So if you had a hard drive, would you talk to it like you would a tape deck? No, you don't send rewind or fast forward commands to a hard drive. So why would you talk to memory the way you do hard drives? Well, you shouldn't, and that's exactly what this does. So it's very critical to understand it's very different. What that means to the application is that these can be used as memory through DMA addressing for certain applications, or they can also show up like a block device, and that makes it easy to use for applications. So it will actually show up just like a hard drive inside your system if the application wants to use it that way. So what we do is we partner with the most innovative companies like Adobe to bring this technology, and it's not enough to just have the system itself. You really want to optimize for the application, and that's really where we turn to Adobe to say, well, what can you do with this? How can you really pull the maximum out of this technology? And I think that's what we're about to see in a few seconds.
Yeah, basically, there's kind of a funny story. We first started working really closely together, I think in August, at SIGGRAPH in Vancouver, and we were on the show floor ripping apart a machine trying to see if it would work. And essentially, we're so blown away with the results. The whole point is that going back from an After Effects perspective, to preview what you're doing as quickly as possible to get the machine out of the way and work at as high a resolution as possible is the core to going from whatever is in your head as an idea to getting it on the screen and seeing if it works. And you'll do it over and over, and again, you'll do it as much as you breathe. So when we turn to the IO effects card and saw how we could optimize it, I want to give you a little bit of an idea of that.
I'll give you the help.
So basically I'm just going to move over to the Windows desktop that I have set up for the demo. So just to give you an idea of what global performance cache is, this is a typical scenario for After Effects. After Effects is going to render the frames. It's going to put that frame into memory. You can see a little green line down at the bottom. And just up at the corner, you can see, well, I'm getting about 3.8 frames per second on this workstation. And that's the way After Effects always works. The other side is you'll notice that the layers for this composition span the entire comp. So, while in every other version of After Effects, this is generally what would happen. If I go in and I make a change to that, and I say, I'll just even take this effect off. Now, normally what would happen, all those green frames are gone, and I would re-render. Now, this is a lot of nested comps, so I would be back to 3.8 frames per second. The difference is that, again, we reuse, recycle, repurpose. And just to give you an idea of that, I'm going to open up this, and I'll show you what we've done on a cache layer perspective. You can see, wow, there's still a lot of information there. We haven't thrown everything away. And that's what every release of After Effects has done in the past. So the global performance cache is really oriented, again, how can you reuse, recycle, repurpose? And if I hit the spacebar now, and I recomposite those frames, you can see the frame rate that I'm getting from that perspective, and it's in real time, because the render takes basically no time to really just modify that one layer. So that's a huge performance improvement. And if you're an After Effects user, that is a very, very big deal. Now, I'm working on an HD comp, and I'm working in 8-bit in this composition, and that's cool, but this is where we really wanted to see how far can we take it. And that's where the Fusion IO folks stepped in, and we really kind of went to the next level. So I'm going to open up essentially just something simple. I'm going to open up some footage that is, well, it's 5K red. And one of the things you'll notice is that I've got this down at 32 bits per frame, which means I'm going to create a frame size of about 2 megabytes per frame from that perspective. And those of you who use After Effects know that it works in RAW. So this is not a compressed format whatsoever. What I'm going to do is I'm going to move After Effects to the side. You'll see this little performance monitor here, and it's going to tell me how many reads and writes per second I can get. And I'm using 2 Fusion IO cards, basically rated together within Windows. And now what I'll do is I'll just hit the spacebar. Now obviously we have to, oh, sorry, I'm just going to move that to the beginning. And then, again, these are big, big, big frames. There we go. So from that perspective, what I'm going to do is I'm just going to do a spacebar preview. And now what it's doing is it's checking that stuff. It's reading the raw footage at this point. But at the same time, what's going to happen is the global performance cache is going to cache those frames to disk from that side. So as an example, as soon as I hit stop here, just from that side, you're going to see the data on the yellow spike as it writes those frames. And Murphy's Law of the demo, there we go. And we're getting about 1.3 gigabytes per second of write on one of those cards. So here's the deal. Each frame is 200 megabytes. If I want to bring those back, I want to make a change to that. Again, I want to work at the highest resolution possible. From a creative perspective, and that's obviously part of what we're talking about today, what does that mean when you compose your composition? What does that mean if you can work at higher res, make changes faster, and get that idea from your head and onto the screen, and go from there? And so the interesting thing is, just really from a quick demo perspective, I'm going to add a simple, we integrated a product called SpeedGrade that we brought into Production Premium for CS6. And again, you'll be able to see a lot more about that at the booth in instant sessions, but I can put basically a look from SpeedGrade right on top of my footage here. And the nice thing is, again, I'm not going to have to re-render everything and go from there. I'm going to be able to get a much faster frame rate back. I'm going to be able to check that into memory, and I'm going to be able to read that from disk at about 2 gigabytes per second and go from there. So that's a brief demo of global performance cache. Again, really encourage you to go check it out at the booth, and it's obviously in training sessions, and talk about the impact of that, I think, in the next.
I think we'll be talking about those things. I believe we're going to have Steve next. And Steve, I'll let you. You can sit, you can stand, whatever you would like. Please.
Thank you.
No, absolutely. Oh no, I'm kidding. You gotta let me do this. We talked about some of the future, some of the things that you think and see, and some of how these advances change stuff for filmmakers or whatever notes you have, which I'm sure will be interesting. But I gotta read your bio first. By the way, you don't have to. I want to. Are you kidding? You're served as a Fusion.io chief scientist since December of 2008. From 71 to 76, you held engineering positions within HP, and you co-founded this little computer company in like 76. I think I bought one in like 78. I think I had an Apple I or an Apple II. And it goes on. 85, you involved in various businesses. In 2000, you were inducted into the National Vendors Hall of Fame, the Heinz Award for Technology. Steve Watson.
Although I'm not technically from this community, I really appreciate everything I see that reminds me of the cool people, the people that actually make things, make videos and that sort of thing. So this relationship between Fusion.io with some hardware expertise and Adobe with the great software expertise, I really like to see that kind of collusion or partnership. Since we have two Steves on here, you could call me Woz. We've already had two Steves before in the past. Sure. Now, you grow up, in computers, and you tend to think creativity is very important. Creativity is like designing things is what some of us think of, and some of us are artists more than others. But, creativity is how the brain is wired, and we really never knew that. Artificial intelligence just doesn't know where things like memory are stored, how they're stored, and how the whole brain works in the sense of a computer. Well, we have some scientists at Fusion.io that have actually uncovered the formula, and we now figured out how to create an entire human brain. It takes 9 months. My personal interest has been less in the big enterprise, the big company stuff over time, and more in what a person can use to enhance their own lives. The little guy who gets a little device at home and says, wow, I can create some software, I can share it with others. I might even start a company now or someday. For me it started with a little transistor radio, and when they moved up to a 6-transistor chip, I said to my dad, now we're going to have better radios. And he said, no. He says, all this new technology, the state of the art, it's so expensive, only the military can afford it. And so what falls out years later, surplus it's called, that's what you consumers get in your devices. Well, now I'm kind of proud because PCs sort of took over creating the highest level of technology, the fastest processor in the world, and now it's games. How consumer can you get, more than PCs and games, and iPods are turning the world over. iPods really make the Fusion.io technology possible because the amount of NAND flash being used, it makes it the premier memory product. It makes the prices drop so low that all of a sudden we've got much better price to performance than hard disks in an awful lot of situations, especially in this creative world. Creativity, of course, is subjective. Everybody has their own idea. You know it when you see it. But then sometimes you see things in terms of what others around you are saying. So sometimes it's human-driven rather than creativity is really an absolute thing. It's very difficult. You can't ever put a formula to it and describe it. Sometimes creativity goes like fashion for that reason. Well, in the early PCs, we had some very hardcore geeks working on it. And hardcore geeks aren't normally the artists in that sense. They're not normally drawing pictures and shooting videos, So we didn't really talk about that was the key application. Of course, we thought we're going to increase creativity by using more of the human brain now that we can build interactive machines. And, so some of us were able to be very creative with how we hook certain chips together. And all that was how do you do more with less? And a lot of the creative work is how do you get more done in your art? Your art might be video, it might be the post-processing, like the After Effects. How do you get more done with less effort, less time, fewer resources? That always makes something better and it makes it more valuable. Something to learn early on in life. So now these tools that we create, do they empower creative humans to use their creativity, or are they the creativity? That's sort of a dichotomy. We always say the human is the creative element, and the technology is the tool. And that's been sort of true to this day. When we started out, we thought word processors are going to help creative writers write better because they can reorganize their thoughts and have more ability and more control over what they're actually going to publish. And then eventually it was words have more, pictures have more meanings than words to people. The world of graphics had to come. This was with the Macintosh type computers. We'll build better fonts that look the way humans do things. Every time the technology gets more like a human friend and works that easily with you, it's better. And that certainly applies to video post-processing. Early gaming, we discovered that you could put numbers into memory and have colors pop up on a screen. Oh, a mathematician instantly realizes what you can do with that. But it wasn't even mathematicians, it was young kids who wanted to create a game, who had an internal desire to do something. Not a salary, not a paid position, not a lot of education. They just wanted to play around with those little numbers in memory and make things move around and make games and make animations and that sort of stuff. And out of that grew this world. Apple built the Macintosh type computers, the GUI computers, with a core based around graphics. And that came in early days. And then because of that, our Macintosh computers needed more memory. A young high schooler might have an Apple IIci with 8 megabytes of RAM. Here comes time for Photoshop. A typical PC in those days had 128 bytes of RAM. How could you influence something like Photoshop with Premiere on those machines? So of course, Macintosh became very popular and took over a lot of the early software in this very creative, production world of audio and visual. And these programs, once they were out, whether it was audio, little keyboards that could type things in and notes on a screen, they were for the average person. They were for the masses. They were for the young Joe at home, the guy who had nothing. And so was Premiere. Premiere, I taught 10-year-olds how to do their video editing with Premiere in its earliest days. It's so interesting. I don't do it anymore because once a whole ton of people are experts, then I'm kind of nothing. I'm not. All of a sudden it shows up that I'm not an artist in that way. But I love to do things when they're new because then you're all alone and you can't be compared to others. The internet came along and the internet let us see what other people do that's creative. And you think of YouTube right away and all the little videos that so many people around the world have been creating, and you never had access to this big world before the internet that lets us share everything kind of democratically. A long time ago I wrote a program to solve the knight's tour where a knight hits every square on the chessboard exactly once. And I had a computer that could do 1 million things a second. Unheard of speed compared to a human. And the program sat there, nothing came out. And I went back and then I recalculated it was going to take 10 to the 25th years. So what that taught me was a computer by raw speed isn't the total solution. The solution is the creativity that's in a human's mind to come up with better approaches to solving a problem, better algorithms. So the human brain is very important. And at that time, I never felt that technology would ever equal the human brain, although in recent times I'm kind of finally this year backing off on that idea. In the future, we're going to have computers that do think and they do feel. And already, who do you ask? You used to ask a smart person a question. You use their brain, their creativity. Now you ask somebody whose name starts with G-O. For some of you it might be God, but for me it's Google. And I get back all these answers more than any human could give. And I just talk like a natural human. I'd like a reservation somewhere at 8 p.m. and I get the reservation through Siri and programs like that. And, will a computer ever be able to sit there, once we've done our work on the movie, play it back itself and analyze it the way a human would analyze it? Was there a mistake? Did something cut at the wrong point? Were some of the words that were used at one point in the movie incorrect compared to something that was said later? Will programs be written that actually detect these things and then tell us how to correct our movie? And we'll look, the program will tell us, oh my gosh, you've got to correct this flaw here, and here's a flaw there, and here's something people are going to detect there, and we'll go and make the movies a little bit better, won't we? And then you have to say, is the machine helping us be creative, or is it the creative element? And is it aiding us, or is it creating? And all I can say is, you'd have to ask Watson for the answer. Thank you.
And how do you deal with that in the budget?
For me, the time component and the deadline is something that you really can't change much. The only thing you can change becomes a production problem. If you don't have enough time to do it, then you just scale up, get another computer. Like the demonstration, it took 19 and a half years to obviously get more computers to do it. So you tend to solve the problem by saying it can't be done. It can be done. You just have to figure out what the ramifications are, what it takes to do it, and then have Same thing happened on Titanic. It was like, well, it took so long to run the water, we'll get 200 computers. I mean, even a crazy thought like that is cheaper than postponing the film. So just get more stuff.
Have you had filmmakers who at the beginning balk at that sort of stuff, and then later you go, if you just listened to me in the beginning?
Well, that happens all the time. And that's, again, everybody says no instantly. It's like, no, that can't be worked out. That's cost too much. That's crazy. It's like, yeah, a lot of things are crazy that are now inventions that we use every day. They're, when they first come out, they're never embraced for what they're good at, what they're capable of. It's always, oh, we don't really need that. We don't, who needs an iPad? Who needs an iPhone? Who needs all that stuff? Then all of a sudden, it's like, I mean, you can't live without it at a certain point. So the genius of the person who comes up with it, and then the other, my particular cases, I use the genius to others and say, you know what? It's a scalable issue. If it takes 2 hours to render a frame, it takes 1 hour with 2 computers, and then you keep on scaling up, and all of a sudden, that crazy idea is not so crazy anymore. Then somebody else finds out how to make it cheaper, faster, better. All those things happen just about every year anyway. So I never rule out the crazy idea. And at some point, it's not even my call. I'll just tell you what it takes to do it. And if you wish to continue to have this shot in a movie, or you want to make a movie that's like this, like an Avatar or something like that, then you just want to overcome those issues. Jim Cameron wants to overcome them. Other people want to say, well, that's too hard, you can't do it. And that's why Jim Cameron made a film that grossed $2.8 billion.
Absolutely. And I want to even link that further to about what everybody is up here on stage for. And I want to kind of start with you, and then there's a follow-up that really falls into your domain very, very well. But what do you, Rob, feel like the limitations of some of this technology are? Do you have an idea where you think it's going?
Well, the technology is limited, like I pointed out with my example of 10 to the 25th years. And I think where it's going, eventually I think, but it's so many decades off, that we're going to have computers that are conscious, and they figure out their solutions to their problems. But right now we need humans to figure that out. Scalability is very important, and one of the things that has made a lot of different computers successful or less successful in their areas has been their scalability. And even when we started at Apple, the fact that we conceived of a machine that could do one little simple task and be very useful to a lot of people, but we built in so much expandability that really let us take over the world when things came about like, okay, VisiCalc, a spreadsheet. All of a sudden, somebody, a creative person, an accountant, if that's not an oxymoron, figures out that in 1 hour, plugging in income and expenses month by month by month, they can do all the work that would have taken them 10 years with pencil and paper. Oh my gosh, what an incredible tool, So every time we come up with a new tool that's it's useful, but those tools, it's great when they're expandable. Nowadays, in the days of networks, we tend to make things that you can plug in, like our Fusion I/O cards. You can plug many of them into the PCI bus, and it just increases the speed and increases the memory and the performance. So we're so glad. I'm so glad to be a part of indirectly the technology that makes this kind of creative stuff possible.
Sure. And it immediately begs for me it's almost the same question I want to ask Rob. Where do you see where it's going? Where do you see the next step with this technology?
It's almost hard to calculate what the next step is, because somebody has to invent something that you now take advantage of, incorporate it, and start it over again.
I think the four of you just work this out for us.
Hey, we'll get back to you in a couple hours.
The next step usually just implies an increment. Where's the final step?
That's Rob. Where do you see the next big challenge as far as this technology? Is it 3D? Is it going to be maybe some of the higher density screens?
Well, one of them is real time. Anything real time, anything is going to be huge, because it now makes it possible for somebody to make 1,000 mistakes in a very short period of time. Like the previous thing, it still takes me a while to have it set up. It still takes a while to actually get a shot. Well, imagine if you did 50 of those shots, you get pretty good at it.
I really like that shot. For me, a lot of ways, it's like almost like a money shot of that film, just how gorgeous it is. And it makes me recall your other Oscar for Titanic, the King of the World shot. How's the technology really changed? I mean, it's in some ways this huge flying overarching camera shot. How's this changed for you?
Well, it changes quite a bit, except that we always now push everything to the very limit. Like on Titanic, we use every last bit of computing power to get something and to reach a goal that was nearly impossible to get to. Well, now that we could have done that shot on a laptop in a couple hours. Now we basically the same excitement of when a shot like that was created to make a shot now that's created. We tend to not use it to save money or to do what we've done before, because I guess we're in the business of not doing what we've done before, do something we haven't done before, is we basically just keep on pushing it to the absolute limit, and then we wait for the next stream of technology to say, okay, now I can even go even further still, because now I can do that shot in this period of time, so I can make it even more complicated. It'll still take a year to do it, but I'll make it so complicated that insurance need to get tired again.
So you used a lot of these Fusion I/O cards. I'm curious, and I'm just going to move this back just because I've got such a list of people up here. Steve, when you found out first what Fusion I/O was doing, what made you want to get involved? I'm sorry, Waz. Let me do it that way. You're absolutely right. Waz, what really made you want to get involved with it?
Well, at first, the first thing is, I get a lot of technologies presented to me that are new and forthcoming. This one was close to my heart, computer architecture. And they had thought about the problem of storage being very involved in time and processing time, how long it takes to do things with a computer. Only everybody was thinking, oh, solid state disk. We take our little camera cards, we take our little phone cards, and they plug in and they look like disks. Maybe you could replace a hard disk with those. And instead of making a little disk replacement, they thought about making a card that plugs right into the PCI bus near the processor with a lot of middle steps taken out and conversions of data and spreading it out to several disks to try to increase the speed, and still wound up in some cases with performance aspects that were 100, 1,000, 10,000 times as great. Generally in total end-to-end comparisons, 10 to 1 performance increase over the competition, which was the old hard disks of the day. Everybody else sat there saying, no, this is the wrong direction. But I recognized as soon as I heard it, oh, they have thought of something, a different path, and that's where the world's going to go, and that's where the world is going now. Plug it right into the server where it's most effective, and every little ounce of performance matters. So I came to love the company, and I was shocked when they asked me to join them in a later date, and I said yes instantly. I thought I'd just be, advisory board, something like that.
Yeah, wow. Yeah, wow. The immediate thought is Rob, like, how did that, I don't mean to make this just, pure Adobe and Fusion I/O, but how did that change your life? Because I assume that this card meant things a lot easier, Rob.
I think it's going to change my life. I haven't received it. But I'm looking forward to it.
If it makes you feel better, neither have I.
A big point in my life was actually when Vince joined the company, brought in and showed us demos of how he could render some sort of real time coming out of 19 channels, for the left eye and 19 channels for the right eye, and 60 frames a second, and make changes to the video as it was running real time. That just blew me away as to how different that was than the slower hard disk before.
Could really use it. It was actually used on Hugo. But in my work and all that stuff, we could really use it.
I'm sure somebody here, when all is said and done, Rob, I'm sure they're going to come talk to you. And you just need to, send me a check later for that, okay?
Time is money.
Well, one interesting thing, just to comment, it's really a symbiotic relationship. When it comes down to, I'll recall, I think it was a couple months ago, I was showing you the 3D camera tracker in After Effects, and of course Rob took it and said, well, can you do this, this, and this? And I'm like, oh my God, I don't know. The whole point is that they take the technology and they stretch it, they break it, they move it in different directions. And then that has a requirement on us as a software layer, and then bringing that back onto the performance side. How do we